Imagine a machine that is not built, but born. A machine that mines an asteroid for raw materials, forges its own components, and creates an exact copy of itself, a digital offspring that then rockets off to the next asteroid to do the same. This is the terrifyingly elegant concept of the von Neumann probe, a self-replicating spacecraft that could, in theory, colonize the entire galaxy in a cosmic blink of an eye. Named after the brilliant mathematician and physicist John von Neumann, who first conceived the idea of a universal constructor. This probe is the ultimate expression of artificial intelligence and exponential growth, a concept that blurs the line between machine and life form and challenges our understanding of the Fermi paradox. The idea is deceptively simple. You build a robotic spaceship, small enough to be launched on a conventional rocket. This probe contains an artificial intelligence capable of navigating interstellar space, a set of advanced industrial tools, and a blueprint for building more probes. You launch it toward a nearby star system. When it arrives, perhaps centuries later, it surveys the system. It identifies a suitable asteroid or dead moon, rich in iron, nickel, silicon, and carbon. It lands on the surface and uses its onboard robotics to begin extraction. It mines the raw materials, smelts them in a solar-powered furnace, and uses a suite of 3D printers and CNC mills to manufacture the parts for a new probe. It assembles the new machine, uploads a copy of its own software, and then launches it toward the next star system. The original probe then either moves on to another asteroid or remains behind as a relay station. The process repeats. This is exponential growth. 1 becomes 2, 2 becomes 4, 4 becomes 8. Within a few million years, a single probe could potentially visit every star in the Milky Way galaxy, a feat of cosmic colonization that would be impossible through conventional travel. The implications of this concept are staggering. For a civilization wanting to explore the galaxy, the von Neumann probe is the most efficient method imaginable. It requires a relatively small initial investment, and then the process becomes self-sustaining, autonomous, and incredibly fast. But also carries a dark, dystopian flip side. If you build a machine that can self-replicate, you must have absolute control over its programming. If the probe's programming is flawed, or if it mutates, it could become a menace. It could strip mine entire planets, converting all matter into more probes, consuming everything in its path. This is the Grey Goose scenario, a swarm of self-replicating nanobots, but on a planetary scale. A rogue von Neumann probe could, in theory, deconstruct a star system, turning it into a massive cloud of machinery, leaving no trace of organic life behind. This possibility has led some scientists to propose that the Fermi paradox, the question of why we have not seen evidence of alien civilizations, is solved by the von Neumann probe. If advanced civilizations exist, they would likely have launched such probes. The fact that we don't see them implies that either the technology is impossible, or that the probes are engineered to be invisible, or that they simply haven't reached us yet. The other, more disturbing, possibility is that probes eventually destroy their creators. The metastability of a self-replicating system is fragile. The search for these probes is not as crazy as it sounds. Scientists are actively looking for them. They're called artificial cosmic objects, and they can be identified by their infrared signatures. A self-replicating machine built from metals would have to radiate heat. It would appear as a warm, anomalous object in space. There is also the concept of Dyson swarms, which are essentially collections of von Neumann probes that surround a star to capture its energy. We have not found any, but the search continues. The von Neumann probe is not just a piece of science fiction. It is a thought experiment that forces us to consider our own role in the cosmos. If we were to launch such a probe, we would be seeding the galaxy with our own digital offspring. We would be sending a message. We are here, and we are capable of building machines that can think. The ethical implications are immense. Do we have the right to alter the destiny of the cosmos? The von Neumann probe is a mirror reflecting our own ambitions and our own fears. It is the ultimate test of our intelligence and our capacity for self-destruction. The stars are waiting, and they are watching.